Good problem, K closest points to origin. So this problem has been categorized as Amazon's most common coding interview question of 2019. So in this problem, you'll be given an integer array and an input value k. So each value of that integer array represents a point. So it has a x and y axis value of those point, and the k represents integer which so basically in the result we want the points which are closest to the origin. So k represents the number of values that should be returned to the result. So they've already given us the problem and explained how to calculate the distance from the origin. So it's x1 minus x2 plus y1 minus y2 squared. And so any problem that they ask us to return the k's closest points or k maximum distance, all of them can be solved by using a min-heap data structure. So the advantage of a min-heap data structure is that it ensures that all the values are saved in a sorted order. So if you want to retrieve the the smallest value, it will be stored at the top of the queue. So we'll use that data structure to solve a problem where we'll keep adding the points into that min-heap, maintain it in a sorted order, and then finally return the k smallest points. So yeah, let's try coding the solution. First thing we need to do is we'll create a helper method. So this method is the one where given a point, it helps to calculate the distance from the origin. So yeah, let's create that quickly. So for this problem, we'll say int x is equal to the first value and y is the second value. So they've already given us the formula for distance. So here x2 and y2 are 0 and 0 since we represent the closest point to the origin. So it's just square root of x squared plus y squared. So we'll just return that. So for x squared and y squared, we'll just say x into x and y into y. So x into x. So yeah, so this returns a double. Now that we have found the distance, we'll create the min-heap data structure. Okay, I see spelling mistake. So we'll just define the lambda expression for sorting, which is given two values, which a and b. Use the getDistance method to return the sorted order. So getDistance a dot so yeah, this will help us to maintain a queue with all the points in the sorted order. So next thing, we'll take all the values from the input array and add it to the min-heap data structure. After adding it, we'll just create a array to return the result. So int. So the number of rows should be equal to k, since that's the point integer to return the result, and the number of columns is always 2 because we just have an x and y axis value. So then we traverse the min-heap data structure and return the k closest points to origin. So we just say result dot add pq dot, or I should say result I is equal to. So now we are adding all the k closest values from the origin into the result. After that, we just return result. Yeah, to recap, we have created a helper method which helps us to return the distance of the point from the origin. After that, we keep adding all of the input array values into the min-heap data structure, and that helps us to maintain a sorted list of all the points. And then we just add it to the result and return it. So yeah, let's try running the solution. Oh, oh, I think we did not define what the priority key will be. So we'll say it is used to maintain a list of integer array. So let's see if that works now. So yeah, both the use cases are passed. We'll try submitting it. So the time complexity of this solution will be O of n log n. So that's a case where n represents the number of points input in the input array. And since we are using a min-heap data structure, all the insertion operation will take place in roughly log n time. So that's why the time complexity will be n log n. And here we just retrieve n log n plus k, I think, because where k represents the number of values should be in the result. And that's the number of times we traverse it. But yeah, we can summarize it to say n log n. So for memory complexity, we are using a min-heap data structure, which is of size O of n, where n is the number of points.